Problem number 5 reads, Submarine A moves with a speed of 30 kilometers per hour with respect to still water towards submarine B, which is at rest. Sub A sends out a sonar pulse of frequency 1000 Hz towards sub B. What frequency is heard by sub B? What is the frequency of the reflected pulse heard by sub A? Take the velocity of sound in seawater to be 1560 meters per second. Let's take a look at those submarines. Submarine A emits a 1000 Hertz pulse. A Doppler shifted frequency is received by B, and the reflected pulse from B is received back at A. With this information that sub A is traveling at 30 kilometers per hour towards sub B is at rest, and the speed of sound in seawater is 1560 meters per second, you are to determine, first of all, the frequency of the pulse received at B, and then the frequency of the reflected pulse received back at A. Try to solve that problem before watching its solution. We want to use our equation for the Doppler shifted frequency to find, first of all, the frequency heard by an observer on sub B. The V in this equation is the velocity of sound in water, which is given to be 1560 meters per second. V sub O is the velocity of the observer, which in this case is 0. And V sub S is the velocity of the source, which is 30 kilometers per hour or 8.33 meters per second. The sub A is moving towards sub B, so the source is moving towards the observer, and the rule is then that the sign on this is positive. So if we plug these values into our equation, then we would get, for the frequency heard by the observer at B, that frequency is equal to 1560 meters per second plus 0 divided by 1560 meters per second minus 8.33 meters per second multiplied by the frequency of the source, which was given as 1000 Hertz. If you carry out that calculation, you can verify that this gives you 1005 Hertz to 4 significant figures, and I don't want to round this answer to 3 significant figures. We lose too much information. So that's the frequency heard by an observer on B. The next part of the problem is to determine the frequency heard of the reflected pulse from B back at A. Now we consider B to be the source and A to be the observer. A is moving towards the B, and if we rewrite our information, let's write it this way. The velocity of sound in water is still, of course, 1560 meters per second. The velocity of the source now is the velocity of B, which is 0. The velocity of the observer is 8.33 meters per second. The observer is moving towards the source, and therefore that is positive. The frequency of the source, let's call it f prime to distinguish it from our frequency emitted by sub A, is now going to be simply the 1005 Hertz frequency heard by B. It simply reflects off the stationary B. If we then calculate the frequency heard by the observer back at A, let's call it f sub O prime, that this is equal to 1560 meters per second plus the velocity of the observer, which is now 8.33 meters per second, divided by 1,560 meters per second, minus the velocity of the source, which is 0. We multiply all this by 1,005 hertz. And if you carry out that calculation, you get to 4 significant figures, 1,011 hertz then as the frequency heard back at sub A. All right, that's our two frequencies. 1,011 hertz back at A, 1,005 hertz received by B, and that is the solution to our problem. Let's move on then to problem number 6.